our first example, we're solving multi-step equations. This is a very basic multi-step equation problem. It's going to require us to simplify and to solve the equation before we can get the correct answer. We are going to use our background knowledge over solving two-step equations and what you previously talked about on the slides about using inverse operations and making sure the equation is balanced. So let's begin. The first step that we always need to make sure that we do is to simplify it if we can. We won't always do this step, but it does help us when solving the equation so that we don't do more steps than we need to. So if I'm simplifying, I'm trying to combine like terms, get it in the simplest form. So if I see here, I have a 6 and a 7, and these are like terms. They're both constants. So I can go ahead and combine these like terms. So 6 plus 7 is 13. 13 minus 6x, and I'm going to recopy the problem, equals negative 3 minus 8x. Recopy the problem, make sure that it's organized and that we're showing all of our work. Okay, so now the second step to solving the equation is to always do any addition or subtraction. And this is going to help us move things around. And what I mean by that is I want to try to get all my variables on the left-hand side and all the constants on the right. So in order to start that, we're going to first draw a bar down the side, and that helps us just keep both sides organized. It's very obvious about the left and the right side now. So I'm going to try to remember my constants first. It doesn't matter which one you start with, but I prefer to move the constants first. So I have this 13 over here, and I want to move it over to the right-hand side. Now, 13 doesn't have an operation out in front of it, but we can think of it as being positive. And if a number is positive, we know that's the same thing as addition. And addition's inverse operation is subtraction. So I'm going to subtract 13 from both sides. When I do that, 13 minus 13 is 0. It's no longer there. So I'm going to draw a big V over it to symbolize that for us. I'm going to draw my equal bar. And I'm just going to bring down what I have left over here. I have drawn negative 6x. Now, whatever you do to one side, you must do to the other. So I'm going to subtract 13 from this side as well. Negative 3 minus 13 is negative 16 minus 8x. Okay, so now let's try to move the variables over to the left-hand side. So I'm going to move this negative 8x. Or we can think of this as subtract 8x. If I need to prove it to myself that it is negative, remember that you can always add a line and change a sign. So the inverse operation of this would be to add 8x. Negative 8 plus 8 is 0. It's no longer there. Copy my bar. Bring down my negative 16. So whatever I do to one side, I do to the other. Add 8x. Negative 6 plus 8x is 2x. 2x is equal to negative 16. So I have all my variables on the left. I have all my constants on the right. The next thing to do would be to get x by itself. And in order to do that, what I'm going to do is multiply or divide. And this is getting x by itself. It might not always be x. Sometimes it'll be another variable, but we typically think of x as our variable. So to get this x by itself, I want my coefficient to be 1. Well, in order to get 2 to 1, I need to divide it by 2. 2 divided by 2 is 1, so x is equal to, divide by 2 over here, negative 16 divided by 2 is a negative 8. Okay, so let's talk about some things over here. So all of my red, that first step here, this is all that simplifying step. This is not always going to be done, but if you do it in the beforehand, it will help you along the way. The second step is the adding and subtracting, and this is where that term multi-step comes in. Typically, we're going to do this step at least 2 times. Not always. It might be more, and sometimes you only do it once. So here I subtracted that 13, and then I added that 8x. That is that key there that comes into the multi-step equation. So we're always going to do that second. And then third, to get our x by itself, we're always going to use multiplication or division. 2x is to multiply. The inverse is divide. So if I divide 2 divided by 2, I have 1. So x is technically by itself now. Remember that other key phrase that we've been saying over and over and over again, whatever you do to one side, you must do to the other. And this is helping us keep it balanced. I cannot stress this phrase enough. Now, one thing to always make sure that you're getting the problem correct, and let's be honest, who doesn't want to make sure that we get the problem correct, is to check our work. So I'm going to take this x equals negative 8, and I'm going to plug it back in for x. Okay, so the last step is to always make sure you check your work. A lot of times we just skip this step, but it can be very beneficial to us in making sure that we get the problem correct. And it can help us check all of our mistakes. So I'm going to substitute that negative 8 back in. So 6 minus 6 times negative 8 plus 7 equals negative 3 minus 8 times negative 8. And notice that I put the number that represents the variable inside of parentheses. This helps us show our work and distinguish that, hey, that was originally a variable. So I have, make sure that you follow the order of operations. So I have 6 plus 48. Negative 6 times negative 8 is 48, plus 7 equals negative 3 plus 64. Okay? So 6 plus 8 is going to be 54. 54 plus 7 is 61. Okay, so negative 3 plus 64, if I'm adding opposite signs, I'm really subtracting. So 64 minus 3 is 61, and I take the sign as a greater absolute value, so I've got 61 is going to be positive. So both sides, 61 is equal to 61, so my equation is